We're now at the last video of this section, other uses of policy enhancements. In the previous video, we learned how to replace existing policies. In this video, we'll first create customized secmark types and see how to audit access templates. Lastly, we'll learn to create customizable types. Let's start by creating customized secmark types. A use case for building our own policy is to create a custom secmark type and make sure that a particular domain is the only domain that's allowed to handle this communication. The SE Linux rules that you're about to see create an invalid packet T type and an intranet packet T type. First, we use the touch command to create an empty file, custompackets.te. vi custompackets.te. Now press Insert to add the contents. Save and quit. Now type the command cat custompackets.te. You can now see that the policies have been added to our file. So here's the content that we're adding to this file. With these rules loaded, we can now create secmark rules that label packets with invalid packet T and intranet packet T. The next step is to allow certain domains to send and receive intranet packet T. For instance, Nginx T, which is a reverse proxy application, you'd use this command. We could also create an interface to accomplish the same. Let's see how to do this. Create an empty file, custompackets.if. vi custompackets.if. Insert the contents to the file. Save and quit. Now type the command cat custompackets.if. So you should see the policies added to our file. With that interface in place, the Nginx policy would be enhanced with this line of command. Some applications have privileges that we still want to be notified about when they're used. The Linux auditing subsystem has powerful features to be notified about various activities on the system, and SE Linux enhances those capabilities by supporting the audit allow statement. The audit allow SE Linux statement has a similar syntax as the regular allow statement, but instead of telling SE Linux that the access is allowed, it tells SE Linux that the access, if allowed, should still be logged to the audit subsystem. For instance, to write audit accesses to files labeled with the etc runtime T type, you'd use this line of command. When this occurs, we'll see a granted statement rather than a denial, as this one. From the granted message, we can deduce that the pg sql admin u SE Linux user, called umount, which resulted in the modification of etc/mtab. Finally, let's see how to create customizable types. So, to create a customizable type, we need to create the type definition in SE Linux, grant the correct user's access to the type, and then register the type as customizable, so that a relabel operation does not change the type back. For instance, we want to have a separate type for an embedded database file used by end users through the sqlite3 command. By using a separate type, other access to them is by default denied, even when those other applications have access to the standard user_home_t type. Now let's use the touch command to create an empty file. Custom mydbembedded.te. vi custom mydbembedded.te. Next, we add this content to the file that we just created. Save and quit. And now type the command cat custom mydbembedded.te. You can see the policy has been added to the file we created. Next, you edit the customizable_types file located at the context subdirectory and add the mydbembedded T type to it. With those steps completed, all users in the user T domain can now use the chcon command to label a file as mydbembedded T and still use this file through SQLite or other application programs that run in the user domain. Great! In this section, we saw how to toggle SE Linux policy booleans using tools such as setSEBool, and how to get more information about booleans, both from their description and the rules they influence. Next, we saw how custom SE Linux policy modules can be loaded and removed, and which different types of development formats can be used for building custom SE Linux policies. We created our own policy modules to enhance the SE Linux policy using various examples, such as user domain definitions, web application types, and secmark types. We also saw how existing policies can be replaced rather than just augmented with additional rules. Replacing policies is, after all, the only way that a policy can be reduced. In the next section, we'll use various tools to analyze the existing SE Linux policy. This is needed for administrators to verify that the policy supports the security rules that the administrator has in mind, and that confined users cannot break out of the confined domains.